Introduction to Open-Close Principle. Hello, everyone. In today's lecture, we're going to talk about Open-Close Principle. It is often abbreviated as OCP, and this principle is one of the 5 solid principles of object-oriented design, which aims to make software design more understandable, flexible, and maintainable. So we're going to explore what open-closed principle is, why it's important, and how to apply it in the code base. Importance of open-closed principle. So open-closed principle is important in software development for several reasons. First, it enhances the maintainability of your code. By following OCP, you can add new features or changes without altering existing code. And this reduces the chances of introducing new bugs. Second, it increases the reusability of your code. Components designed with OCP can be reused in different contexts without modification. And finally, it improves the flexibility of your software, making it easier to adapt to changing requirements. So OCP helps create software that is reliable, scalable, and easier to test and debug. Definition and explanation. So this principle states that software entities such as classes, modules, and functions should be open for extension, but closed for modification. So this means that the behavior of a module can be extended to meet new requirements, but the source code of the module should not be changed. And this concept was first introduced by Bertrand Meyer, and Bertrand Meyer emphasizes that a well-designed module should allow for new functionalities without altering its existing code. And this is really important because this approach helps prevent regressions and therefore maintains the integrity of the system. Practical implementation of OCP. So let's look at an example that does not follow the open-close principle. So let's look at this, and we have a function to calculate the area of shapes like rectangles and circles. In order to add a new shape, let's say we want to add a triangle, then we would need to modify this calculate area function. Because of that, this is violating open-close principle because we are changing existing code to accommodate new functionality. So if we were to refactor the code to follow the open-close principle, one of the ways you can do is using polymorphism. So in this approach, we are defining an abstract class called shape, and the shape has area method. So each specific shape class, such as rectangle and circle, implements the area method. By doing it this way, we can extend the functionality without having to modify existing code. Therefore, we're adhering to OCP. So adhering to the open-close principle is really important because it brings several benefits. First, it enhances the scalability of your software. So you can add new functionalities easily without modifying existing code. Second, it improves maintainability by reducing the risk of introducing bugs when making changes. Since existing code remains untouched, the chances of accidentally breaking code are minimized. Third, it makes your code more testable and debuggable because each class or module is more isolated. It's far easier to test individual components. So overall, you want to follow OCP because it helps you build flexible and maintainable software systems. Real world applications. So in real world software development, the open closed principle is applied through various design patterns and practices. For example, you can look at Stratis pattern, and Stratis pattern allows you to define a family of algorithms and make them interchangeable. So we have a payment strategy class that has pay method, and we have credit card payment, PayPal payment that is implementing payment strategy. And you can see that they are interchangeable. So in shopping cart, we initialize with we can initialize with credit card payment and do a checkout, or we can initialize with PayPal payment. And another pattern would be the decorator pattern. Decorator pattern enables you to add behavior to objects dynamically without having to alter the structure. Last one would be the factory pattern. Factory pattern would provide a way to instantiate object without exposing the creation logic to the client. So additionally implementing interfaces or abstract classes that can be extended to ensure that new functionality can be added without modifying existing code. Conclusion, the open-close principle is a fundamental concept in object-oriented design that promotes the creation of flexible and maintainable code. So we want to make sure that software entities are open for extension, but closed for modification. This means we can add new functionalities without modifying existing code. And this brings huge benefit because we can prevent bugs and maintain the integrity of the system. Thank you everyone for listening.